Hello. Welcome to No Records Programming Laboratory. This time, I would like to create an AR business card as shown on the screen. As you can see, an image is displayed on the business card, and this is AR. If you search the internet, you will find many services that can create this AR business card, but it can actually be created with simple programming. And it's free. So please take a look at the explanation until the end if you like. First, let's talk about AR. AR stands for Augmented Reality. It is a technology that superimposes virtual information on real images captured by a camera. In an easy-to-understand example, Pokémon Go and Dragon Ball Scouter are also AR. By using AR technology to create a business card, you can display self-introduction, company information, etc. on the business card by holding your smartphone's camera over it. It is often the case that you do not know who someone is just by hearing their name because you have only met them a few times, but with this AR business card, you can easily identify them by displaying their photo and profile on it, which is very convenient. There are several ways to use AR, but this time we will display AR on a web browser. This is probably the easiest way to do it. So let's explain the overall flow of creating an AR business card and actually displaying AR. First, create a web app that displays AR. Then create a business card with the function of displaying AR. Next, ask the user to access the web app. When the user reads the business card using the camera on the web app, AR is displayed on the business card. The most difficult part of this is creating a web app. But actually, a web app that displays AR can be created very easily. For example, the web app that displays the AR that appeared on the screen earlier can be created with just this code. It is 42 lines long, even though it has many line breaks because it is formatted with Prettier. If you have created a web app before, you can see that it is written in a very small number of lines. And it's free to create. It's great, isn't it? Now let me introduce the tools you will use to create an AR business card. A-Frame is one of the web VR frameworks that allows you to create a 3D virtual space on a web page. You can easily create 3D graphics with HTML. For example, you can create a web page where your name or photo is displayed in 3 dimensions. Next is A-R.js. This is also one of the web VR frameworks and is used to overlay AR content on the real world using a web camera. It is written in JavaScript and can be integrated with other frameworks such as A-Frame and AR.js. AR.js has various functions, but this time we will use a function called marker-based AR. This is a function that places AR objects, such as images, videos, and 3D models, at a specified distance from an image with such characteristics as a marker. This time, I'm going to create a QR code for accessing the web app to be created, which will also be used as an AR marker. The last tool you mentioned is Glitch, an online editor tool for creating web applications. It started in 2017 and allows developers to create and share their projects with other developers. The created web applications can also be published as they are. Glitch's free plan has some limitations, but it is efficient to use. By combining A-Frame and AR.js with Glitch, you can easily create an AR business card. Although the introduction was long, let's get started. This is what the test environment looks like. Access Glitch, an online editor. I don't have a Glitch account at the moment, so I'll create one. If you already have a Glitch account, click Login and skip the account creation explanation. First, click Sign Up in the upper right corner. There are 3 ways to create an account, but this time we will use a GitHub account. Enter your GitHub account ID and password to sign in. A notification will be sent to your smartphone, so verify your identity with 2-factor authentication. Now that your identity has been verified, move to the confirmation screen to link your Glitch account with your GitHub account and approve it. You can now log into Glitch with your GitHub account. The screen after logging in looks like this. There are many project templates, aren't there? Next, access the official A-Frame website. Click Get Started. Move to the introduction page and click Remix the starter sample on Glitch. A sample project of A-Frame will be copied to Glitch. 4 3D models of a plane, sphere, square, and cylinder are displayed on the screen. Click Remix Your Own in the lower right corner to move to the editor screen of this sample project. The left tab displays files included in this project such as settings and assets. Let's open index.html. The 3D models seem to be expressed in just this code. It's only 15 lines in total. A-Frame library is loaded in head, and only 7 lines are in body. Tags such as a box and a sphere seem to correspond to each 3D model. The preview screen of this sample app is displayed on the right. If it is not displayed, you can display the preview screen by pressing the preview button at the bottom of the editor. You can change the viewpoint by dragging with the mouse or move around in 3D space with the direction keys. Next, access the official page of AR.js. Click the link Import the library in the left tab. Since we will use marker-based AR this time, copy the code to import the A-Frame version of the library in the AR.js with marker tracking section. Return to Glitch's editor and paste the code you just copied into head. Don't forget to write the end tag of the script. A dialog asking for permission to use the camera will be displayed, so please allow it. Although the camera can be used in this sample app, the processing becomes heavy when the camera is activated in the preview screen of Glitch's editor, so let's close the preview for now. You can close the preview screen with the dots at the bottom of the editor. Now let's rewrite the code to make A-Frame and AR.js work together. Add embedded to the A scene in body. This enables A-Frame and AR.js to work together. By the way, Glitch's editor automatically saves, so you can rest assured. Let's set up the marker image and display the 3D model based on that marker. AR.js has default marker images that can be used, but they are not very good. So let's create our own marker image. As mentioned earlier, this time we will use the QR code to access the web app we are currently creating as a marker image. First, check the URL of the web app you are currently creating in Glitch. You can copy the URL from the dots on the preview screen. Create a QR code from the copied URL. You can create it in any way you like. Search for a QR code creation site on your browser and create it from there. Once you have created the QR code, return to the AR.js official website and click Marker Based in the menu at the top. Click the link that you can create your pattern markers with this tool. You will be taken to a page where you can create an original marker image. Upload the QR code you created earlier from the upload link. The black border is large. This can be adjusted by the pattern ratio value. This time, I set it to 0.80. Remember this value as we will use it later. Then click the Download Marker button to download the pattern file of the created marker image and the marker image itself with Download Image. The extension of the pattern file is PAT and the image is in PNG format. The file names were a bit confusing, so I changed them to marker.pat and marker.png, respectively. Now that you have created and downloaded the original marker image and pattern file, upload the pattern file to Glitch so that the original marker can be recognized. Click the plus in the Files tab on the left. Click Upload the file and upload the downloaded pattern file. There is no need to upload the image file. When the upload is complete, you will be automatically taken to the Assets page, so click on the uploaded pattern file. Then, the URL of this pattern file will be displayed, so click Copy URL to copy the URL. Return to index.html from the left tab again and write the code to recognize the original marker. Write the following A marker tag so that it is surrounded by the A scene tag. Paste the URL of the pattern file you copied earlier into URL. End tag of A marker should be placed around 3D models that will be displayed in the R space. Also, write this A entity just below A marker. This will make the position of the marker image the reference point when displaying 3D models, etc. in the AR space. Finally, add this attribute to A scene. The value of pattern ratio here is the pattern ratio value set when creating the original marker image. That's it. Let's format the code with prettier for now. It's easier to read now. Currently, there are many squares and spheres displayed. So let's delete everything except the squares to make it easier to understand. Be careful not to delete anything you need. Also, change the position of the square to 0, 0, 0 so that it is directly above the marker image. Now, let's use the marker image to access this web app from your smartphone's camera and check if a square 3D model is displayed on this marker. This time, the device is an Android, Pixel 6a. When you access the web app, the dialog for using the camera will be displayed for the first time, so allow it. As you can see, a square 3D model is floating near the marker image. If you use an iPhone as the reading device, it will look like this. When you move to the web app, the camera usage permission is displayed in the same way as on Android, but you also need to allow the use of motion sensors. As you can see from the screen, the 3D model is displayed even if permission is not granted, but if permission to use the motion sensor is not granted, the display position may shift, so be sure to grant permission. It's good that the security is higher on the iPhone, but it's inconvenient that permission is required even for this kind of thing. Let's create the data for the business card once we have reached this point. There are many ways to create business card data, but I recommend using Canva as it is easy to use. Canva is an online design tool that allows you to easily customize templates and use free materials. This allows you to create designs quickly. So I created the data for the business card like this. I put the original marker image QR code, the name and logo of Null Records Programming Laboratory, and the URL of the YouTube channel. You can order the business card from Canva, but to confirm that this business card actually functions as an AR business card, let's download the data and print it first. Click Share in the upper right corner. Select Download and change the file type to PDF print. Check trim marks and bleed and download. The PDF data has been downloaded. Print this data at 100% magnification and cut the paper along the trim marks. I printed it in black and white on A4 paper this time, but when you cut it along the trim marks, it looks like this. It's thin, but it's enough to test. As you can see, a square 3D model is floating on top of the business card. Now let's display proper information on the business card instead of a square 3D model. In AR using A-Frame and AR.js, you can display not only 3D models but also text, images, videos, and more. This time, I will prepare an image like this to display because I don't intend to make anything too elaborate. The completion image is like this. When you tap the guide image, it will move to the general link. Please note that the size of the image to be used must be square. A-Frame converts the displayed image to a 1:1 ratio by default. Therefore, if there is an original image that is not a 1:1 ratio, it will be forcibly converted to a square like this when displayed in A-Frame. Create a 1:1 ratio image with margins in advance. Let's return to Glitch. First, upload the image to be used this time. Open Assets from the left tab and drag and drop the image to be used. Now that the image has been uploaded, let's write the code to display the images in order. First, let's start with the profile image. Click on the profile image to copy the URL. Let's go back to index.html and delete the A box, which is a square 3D model. Write A image so that it is surrounded by A marker. Then, write the attributes of A image like this. The ID attribute is used in the same way as the ID attribute in HTML. You can get the element with the ID attribute specified in JavaScript. Since we don't do any processing with JavaScript this time, the ID attribute is not necessary, but it is attached to make it easy to understand at a glance. The width height attribute specifies the magnification of the width and height of the image. The position attribute specifies the position of the image to be displayed in AR. Since it is based on the marker, it is positioned above the marker image if it is 0, 0, 0. The rotation attribute specifies the rotation axis of the image. Please refer to this figure for the relationship between the position and rotation attributes. Specify a value for each x-axis, y-axis, and z-axis. I think it is easier to understand by changing the value and moving it. The src attribute is the same as the src attribute in HTML and specifies the file path of the image to be displayed. Since it has become longer horizontally, let's format it with prettier. Let's check how the profile image is displayed. The image is displayed directly above the marker, but it stands vertically to the marker, doesn't it? Also, the image feels a little small, so let's make it bigger. Let's adjust the attributes while referring to the completion image. Let's check again. It looks pretty good. Let's write code for other images in the same way. I confirmed that I could write code for other images. The profile image and the arrow are overlapping and disappearing. Let's float the arrow slightly in the y-axis direction. There seems to be no problem. Let's tap the image that tap here to go to the specified link. This time, we want to set the link for the image with the DAR image too. So we add the following link attribute to the image of that image. In this video, we will set the URL of null records general link. Then, we write this A entity just below the closing tag of A marker so that the image can be tapped. In addition, when I open the web app on Android, I notice the VR button in the lower right corner, so I will hide it. Add this attribute to a scene. Let's try it out. The VR button on the lower right is now hidden. When you tap the image that tap here, you will be taken to the URL you set. It looks good. I explained how to make an AR business card using Glitch, A-Frame, and AR.js. It wasn't as difficult as you might have thought, was it? This time, we mainly displayed images in AR space, but we can also display videos and more. However, embedding YouTube videos is against the terms of service, so it seems that we cannot do so. You can also add animations like this. Personally, I don't think it's that effective, but if you're interested, please check the official documentation. AR business cards are very useful in business scenes because you can display self-introductions, company information, etc. on top of business cards. Please refer to this video and create your own original AR business card. That's all for this time. If you found this video helpful or interesting, please subscribe to the channel and click the like button to support me. Thank you for watching.